Okay, this mini lecture is about another player of motion, and we are going to look at speed versus velocity. So this answers our questions about motion. That's how fast. How fast is an object moving? And there's two ways to describe it, speed and velocity, and they're not the same in physics, and so we want to make sure we define them very carefully. So what is the difference? They both say how fast something is going. Speed defines how fast something is going in terms of its distance traveled. So speed is related to distance. Distance over the time that distance is traveled. So this is how we define the average speed. Our distance, our total lengths, divided by the time of the motion. So remember, distance was total lengths. And our time is the time of the motion we care about. We learned how to define that in our time unit. Average is represented by these little triangular crosshatches. So it's a mathematical way to represent average. So the average speed over the whole course of the time is defined as the total lengths for the time of the motion. Now, since it's total lengths and lengths don't care about direction, we don't care about direction for speed either. We are simply saying that speed is a how fast, doesn't matter what direction it's headed. All right. What about velocity? Well, velocity, you might deduce, if speed's related to distance, velocity is related to displacement. So what is the object's displacement in the time that I cared about the motion? So this represents our average velocity. And again, displacement was our change in position over the time of the motion that I care about. And we're going to think about that as the total time of the motion I care about is defined by that initial final. We have to define that motion first. So as another way to represent that change, we know it's our final position minus our initial position over that motion time t. Well, displacement cared about direction. Am I moving at a certain rate? How fast? 5 meters per second to the right? Or am I doing it to the left? So direction matters. Because direction matters in displacement. The direction for velocity is the same as for displacement. And this should make some sense, hopefully, because if I'm moving to the right, then I'm going to end up to the right of where I started. So they should sort of connect to each other. The direction of motion, the direction of how fast I'm going, the moving part, should correspond to where I end up relative to where I started. So direction matters. And if we have direction, we got to be thinking about what those directions mean. So a positive velocity means that I'm moving to the right, or up, or east, or north, using those conventions. A negative means that I'm moving to the left, or down, or west, or south if we use our conventions. So direction is important for velocity. All right, so let's just do a quick example on calculating both the speed and the velocity of a motion. Let's define our world real quick. So here's our position equal to 0. And let's say that I start at, we'll do a very brief example, and then we'll do some more practice ones later. If I start at position, here's my initial position, and here is my final position. So that I'm defining as my initial and final position, but my motion might look different. Okay, so let's define the motion. So I start here, I move 2 meters to the right. 1, 2, 3, 4 meters to the left. So this was 4 meters in length. And then 1, 2, 3 meters to the right. So these blue numbers are representing the lengths I traveled. 2 meters to the right. 1, 2, 3, 4 meters to the left. 1, 2, 3 meters to the right. And let's say I do that in 1 second. So very fast. So my time is 1 second. I don't know what that is. Okay, great. Let's get rid of that. All right. So what is my speed? Well, that's my total length over the time the motion happened, the 1 second. So my total lengths, so my average speed, well, 1, 2, 3, 4, 5, 6, 7, 8, 9. 2 plus 4 plus 3. 9 meters in 1 second. My speed is 9 meters per second. I traveled a distance of 9 meters in 1 second. 9 meters per second during that motion. What is my average velocity? Well, that's my displacement per time. So my final position, 2, minus my initial position of 1. The time still took 1 second. So that's 1 meter per second. It's positive. To the right. On average, even though I went like this, on average, I moved to the right over that 1 second. And I only moved 1 meter in that 1 second if I'm thinking about where I started. But for speed, I was going crazy back and forth. I was moving really fast. So it's represented as a higher number. So we have to be very careful about whether we're using the word speed or displacement. Speed or velocity. Speed cares about the lengths, and you have to know what's going on. It's path dependent. You have to pay attention. Velocity, you just have to know about where you started, where you ended, how long it took you to in between. So we'll get some practice on that in the homework problems. Velocity is direction, important. If we have a positive velocity on average, we've moved to the right. A negative velocity on average, we've been moving to the left, or up and down, depending on what your dimension is, east, west, or south, forward, backward. Now these are our average speeds and average velocities. One of the things we want to pay attention to, and especially as we do more problem solving, is that in terms of velocity, we are going to be talking about an instantaneous velocity. And that's the velocity at a very specific point in time. Perhaps I'm interested in how fast is the object going when I first care about the motion. What's its initial velocity? And how fast is the object going when I stopped caring about the motion? What's its final velocity during that time frame? So we're also going to be thinking about and paying attention to average velocity, as we've defined, and instantaneous velocity. As we develop more skills in terms of defining these ideas, we'll look at how we calculate the differences between those two. You've been given average velocity, but what does it mean to have an instantaneous velocity? So we'll get to that in a later mini lecture. But for now, by just thinking about what this player means, these are how we define how fast something is going. We use two different ways, and we have to be very careful and very intentional about using the proper words for the player, for the description, and how fast we're trying to define. All right, good job.